one of the things that Phil Anderson did while he was with us, and was he started a series of lectures called Science, Technology and Society. This was, to say it was becoming fashionable is not correct, but it was becoming less academic. That science also had things to say, and it was involved in practical living, not just fundamental particles. And so he started a series of lectures, of one lecture per week in the winter term, so that's 8 lectures, which he called Science, Technology and Society, and I helped with. And these were invited lectures by different people from around Cambridge. We could have had people from other universities and so on, but there are enough people in Cambridge who have things, important things to say. And so they were all, in fact, Cambridge people, one a week. And it was interesting that it was part of our final year physics curriculum, in principle. I mean, the final year was had several options, and one of them was this course. The question arose, how can you examine it? And the answer is that Richard Eden, do you know? No. He was a high energy particle theorist, but he gave that up and started a group on energy theory, use of energy. And I remember, for example, one of the first things his group did was to write a report for the government of how long would it take and how much would it cost to put proper good insulation into the ceiling of every house in the country. And the answer is it could have been done by the 1990s. Of course it wasn't done. Anyway, that was, so Richard Eden also had this kind of wider interest and became involved. And yes, these were all individual lectures. I remember one was, they were called, what were they called? Well, it was becoming, in the 1960s, the impact of science and the environment had started. And one of the first books was by an American scientist, Rachel Carson, called Silent Spring.
Yes.
Very important. That was the first one, really, of this new movement.
Yes.
So it was following on from that, suggested these lectures. I can't remember. Yes, test tube babies. Well, it wasn't, they weren't test tube babies, but it was artificial insemination. The baby was born in a person, in a woman. But the artificial insemination. And I remember that was something quite new, and a lot of people felt it was shocking. And in village Bourne, outside Cambridge, was a clinic. And that's where it started. It started from Cambridge Hospital as a research group. And then they set up and set their own clinic in Bourne. And the first public lecture on the subject was in one of our series.
Right.
So that was interesting.
What roughly was the year, time?
What?
What year, what time, roughly, was this?
This was starting in around 1958, maybe, something like that. Then Phil Anderson was until sometime in the 1960s that he then went back full time to Bell Labs, but I carried this on until about 1980. Yes, it must have been 68, I think, because I think there were 12 lectures, 12 years, and I finished around 1980. And yes, I carried it on with the help of one or two other people that I attracted, and after Phil Anderson had gone. So we continued that, yes. Yes, so yes. I'm trying to remember other specific ones. Though certainly on climate change, that was the first time I remember discussion of climate change. Was in one of those lectures towards the end of that time, near 1980.
Right.
Yes. Oh, and of course, yes, in the early 1970s, we had the first oil shock when I can't remember what, I think it was the oil producing countries that decided to shut off the oil wells.
Yes.
And I remember petrol being rationed, and we all learned to drive much more gently, so that the gallon of petrol went nearly twice as far. Yes, I remember that. And of course the insulation, I mean, everybody started then to insulate their walls, the cavity walls, and fill it with polycyanid. Yes. Including we did, and this house was done before we actually moved here, so that became general, yes. But yes, and in the loft up there, yes. So that was, I mean, these lectures, well, they didn't belong to any group in the Cavendish, but they sort of came, yes, they belonged to our group.
Right.
This is one of the things that we did.
Then how to assess students who take the course?
Yes. In part of the final year exam, there was one paper which was not an exam paper in the usual way, but the students had a project where they had to write an essay. And they had to write the essay in the examination room. So they couldn't just copy it from somebody else or anything. It had to go through their brain in the examination room. But the Richard Eden, who had this energy group, always produced a topic, and it didn't matter if it was the same topic or similar topic, but so that was how it was examined. Yes. Good question. Yes. One of the things I see that I hear was about our secretaries. At that time, each research group had a secretary and sort of office organizer. And then when the TCM group started to really develop a bit, we got a secretary.
Who don't?
This was in the about 1966 or so, about then.
Right.
And she was called Susan Cattell, and was the daughter of a farmer, and his wife was a school teacher, and they lived in a village near Cambridge. I remember the first day she came, one of the things that she did was to type out the list of the group, including the visitors and so on, and of course the graduate students. And she typed that out, and then showed it to me, and as the secretary was a member of the group, she put her name at the bottom, and I said, no, your name's not at the bottom, you're up after me at the top. Secretary is a very important person in communication within the group,
Right.
and keeping well, she was rather surprised at this, but that was my New Zealand instinct. In New Zealand, women were much more important everywhere, on farms, and this was part of the culture.
Okay.
And so this came naturally to me, that's how it should be, and that worked well. I mean, including, you see, we had always several overseas visitors. I mean, usually one or two were maybe paid by us, a research grant, but 2 or 3 others would be just coming on their own money, but be part of the group as academic visitors to the cabinet.
Yes.
And so we had quite an interesting mixture like that. That was part of the nice things. Yes, and well, so in England, the government regulations and university regulations are very strict about claiming travel expenses if you go on a trip.
Right.
You have to have receipts, and you have to have a proper list of what meals and so on. Some people were not used to that. They came from cultures where, well, if you're a professor, you just present some kind of a list and claim back at the end. So she had to explain the English Cambridge system to people who were, you know, quite senior professors in their own countries, and she was just she'd been 2 or 3 years out of school, so she had to have the personality to cope with this.
Right.
Yes.
Right.
So we were. So it was an education for the secretary. Really, to be in our group and to be yes, I mean at the top under my name as a list in the list of the group.
Right.
But this was also part of my New Zealand culture.
Right.
So that was yes. She then married, in fact, a graduate student from Canada in a different department. Also on the Cavendish site, on the same site, but not in the Cavendish itself. And they went to Canada. Yes.
The secretary of our time when I was a student was Sheila Johnson. Sheila Johnson.
Oh yes, Sheila. Yes.
That was the time when I arrived in TCA.
Yes.
Sheila Johnson was the secretary.
I notice here that many years later, I mean, well, some years later, Susan was deputy, when she retired, yes, she was deputy head of the English school in Cairo, an English language. There are English language schools everywhere in the world,
Right.
including in Taiwan, maybe.
Yes.
Do you have an English language school in Taiwan?
Yes.
Well, she was deputy head of the English language school in Cairo, in Egypt.
Okay.
So, I mean, they were very capable people, but I think we helped to make them capable people. We made these demands on them, and they blossomed like a flower.
Right.
And I was very pleased with that, because in other, in a different culture, they would, but in the New Zealand culture, as I developed it, they were wonderful. Yes. Okay, that's. I think we need to think as to what else we should talk about. Well, here is a bit that shall I just read it out? It's
Yes.
about Sam Edwards.
Yes, and also allow me to remind you, the name of Mike Payne, Richard Nees, Rex Godby, they not yet appear in your story.
They didn't exist. I mean, we're in the,
But yes, yes.
we're in the 1970s.
Right. Right. Yes, please, Professor Sam Edwards.
A major expansion of the TCM group came with the arrival of Professor Sir Sam Edwards, working on what I called messy materials, like as polymers, not nice crystalline metals and other regular crystal solids. Indeed, the 1950s had seen an extension of condensed matter physics from the relatively tidy science of perfectly regular crystalline solids, a huge variety, but to a different and more complex world. The first was to note that if one pours sand, or better a set of marbles as precise spheres, into a large container, they will always have a certain loose packed density of spheres per litre. If you just pour them in, they don't form a regular crystal, of course, but they have they're like a liquid, but it was always the same. So it was a real state of matter, like solids, liquids, gases, and loose packed was the expression. But if you then shake them, of course, then they sink. But they form another close packed, I mean, not close packed crystal structure, but what did they call it? A tightly packed density. But again, this is a precise density, within 0.5% or something. There was the loose density, which is reproducible. I mean, you know, whenever you do the experiment, it's always the same. It's not just sort of a random, no, it's a very precise state, loose packed, and then tight packed. And then, and Sam Edwards started research on polymers standing between solids and liquids, polymers with long string-like molecules that can flow slowly. I mean, they flow by what is called reptation, by crawling like a snake. And this was a whole new development of science. The group was on polymer research was by Dr. Athene Donald, later Professor Donald. She's now head of Churchill College, the master of Churchill College. And she had an experimental group on polymers, and Sam Edwards, when he came and out of TCM, but he chose to have a room with them. They were in the Bragg building, the back part of the Bragg building, and he chose to sit there with them instead of up in the Mott building with the rest of us. But again, that was his life, to be the theoretician, deeply included in that kind of work and part of the tea time conversation about what the ideas were, what they were thinking, what they were doing, and why was it, how do you plan the next experiment? What is the precise question?
Yes.
You see, in these loose packed things, I mean, it was not realized that there were these two precise entities, loose packed and random, and random tight packed, but that they exist as phases, and that was, I mean, that's the sort of thing that came out of, I mean, it was involved at that time. Yes, not long after he came to Cambridge, Sam Edwards became the head of the National Physical Sciences Research Council, and so worked in London. But he commuted from Cambridge. He still lived in Cambridge. I mean, this was an appointment for a few years, not just for life.
Right.
And so he would travel to London, and he would continue to have research students, and he would supervise them in the train. He would take a first-class carriage, so that even in the rush hour of going down for work, they could have a compartment and have a physics supervision for a graduate student. We all thought that was lovely. And then the student would turn around and come back, having been supervised on the way down. Yes. There were other people, of course, who came at that time. Also, Mark Warner, I think, was the obvious one, and I haven't written in the. I'm not qualified to say anything about his work, so I had to leave it. I don't. But then other people. Richard Needs started as a research student on electron gas, many-body theory of the electron gas, and how it worked in practice. And then he became a young staff member. I forget what he did. He didn't stay with that with the electron gas, but I forget what he did do then. And then after that it comes into the modern world. I was stopped being head of the group, and other people came. Yes, I commented here that Phil Anderson and we would have a lunch together at a quiet pub outside Cambridge every Wednesday during the full 8 weeks of what we call full term, you know what that
yes.
Talking about the affairs of the group, but also about the world of physics more widely.
Right.
And that was very important. Yes, and then Mark Warner, who later also became a professor. Now, I developed around this time, around 1980, a totally different collaboration. One day, I always worked with my door open. I had the corner office. I must have, while you were
Yes,
here.
yes,
Uh,
yes.
And the door was always open.
Yes, yes.
So that coming down from the coffee area,
Yes.
the door was open and you could see if I was there
Yes,
and,
yes.
and whether there was anybody with me. Of course, if it was having a confidential conversation, we closed the door. But if I was by myself, I would just
Yes.
work by myself with the door open.
Right, yes,
So
yes.
that is symbolic.
Yeah.
That says you're welcome here
Mm.
to come in. And one day, a big man stood there and said, you know something about group theory, because I'd written my book, listen to this. And that was Des McConnell, who was senior lecturer, maybe already a professor at that time, in earth sciences, in the mineralogy group of earth sciences, and came to me to discuss some of the clay minerals that he was dealing with. They do not have a regular crystal structure. One of the, what is it, 290 something, 300 something.
230 space groups.
Yes,
Right, right.
one of the space groups. But they have a modulated thing. And he had worked, he was an experimentalist, worked on these and working out the structures. Of course he knew all about space groups and so on, and showed that the material consists of two slightly different structures, modulated, one with a cosine and the other one with a sine function, and these two existed together, and this was the stable structure of these minerals. I mean, you see, in physics I had learned that materials, pure materials, have one of the, what is it, 300, 200 and something?
Yes, 230 space groups.
230 space groups. It's not true. These materials had these modulated groups. Now, then one of them was a cosine and the other was a sine function, and there were two different structures, modulated with cosine and with sine, and of course there was a relationship between them, because where the cosine function was at its maximum, I mean Q equal to 0, I mean basically a regular crystal structure, the other one was just going through its maximum slope, the sine function. And so it also was a regular thing in the sense that it was a linear slope going through the origin, but not one of the 230 space groups, but something analogous to it. And then further on, half a wavelength further on, quarter wavelength further on, you have the reverse. You have the first structure is now changing rapidly, and the other one is at its stationary point. So it was a whole new dimension to crystallography that he had worked out, and the two space groups and the relationship. There had to be a symmetry relationship between them, but he didn't know what was the physical origin. Why did they do this? And then he and I worked together for on and off for about 10 years. Well, he also went to Oxford as a professor sometime during this time, but we'd already mostly done our work before that. And we would meet at a pub. Because he was from a different department in the centre of town, and I was out in where the Cavendish is, and I would have to go to his department, he'd have to go, one or the other, etc. So we went out to have a lunch together, and there we were not disturbed. Whereas in the department there's always a student or something, there's always things going. And therefore, for many years we would, and then I learned, I can't remember how, but I did, that there are much simpler materials that also have modulated structures. One of them is sodium nitrite, NaNO2, not NaNO3, but NaNO2. Because nitrogen can have different valencies, and so I looked at that and I worked. It became clear to me why, and then we wrote a paper together about that, and then we took one or two more examples. I can't remember what they were, but where with quite simple physics. I mean, sodium nitrite is NaNO2. I mean, it's not a complicated material. And so one was able to do simple physics on these two structures and the relationship between them. And that was something that we did over a period of 10 years or so, maybe a bit longer. As part of my activity, and this was me leading it from where he had developed the crystallography, and then of course we would discuss to some degree, I mean, his complicated clay minerals, why they should do this. Once I had worked out, what is it that can do this with simple materials like sodium nitrite. And I forget, there was another one that was very simple. So that was an interesting phase of research, yes. I can explain, I can give you a little picture. Sodium nitrate is, is a regular tetragonal unit cell, and well, it doesn't work like this, but it's basically a tetragonal unit cell of sodium, and then in the middle is the NO2 group. Simple structure. And the NO2 can be either that way, up or down. And why does it want to do that? And the answer is because it's not very happy. It's a triangular group, NO2, and it doesn't really fit into a rectangular cell. And so the cell is under strain, and it's elastic strain that makes it go there, and that relieves the elastic strain of having this awkward NO2 in the middle of a nice tetragonal cell.
I see.
So that was, I mean, but then we went on to other ones we found 2 or 3 other groups, other materials that had simple examples like this, where we could actually see what was the physics reason for it, and write a paper on that. So that was an interesting phase of my research. Yes. Well, this had a wider spin-off. that the Earth Sciences department, they had somebody who was sort of somewhat theoretically background, but it was definitely sort of based on the Earth materials, it was. But then when Des McConnell became head of the department in Oxford, he introduced a theorist into the department there, and it brought mineralogy from out of the Stone Age, out of the just collecting experimental information about this structure and that structure and this material and so on, and doing a theoretical study of why they did it. And that was a new chapter in mineralogy. And so we contributed to that. That yes, that was, I think, it was quite, I think, important. Yes. As for a few years, I went into mineralogy conferences, for example. Yes. Well, since then, of course, we have continued to fan out. I mean, there are now at least two people who are university staff members, lecturers, well, now senior or professor, I don't know, in the engineering department, ex-TCM members. And the head of the material science department is an ex-TCM member. And one of the senior people in the mathematics faculty is an ex-TCM member. And so...
do you remember their name? Or perhaps I should ask around.
I can look up the person in Earth Sciences. I'll do that. I'll go down to this.
Okay.
So you can switch off.
Okay.